All right, first off, do you guys have any questions? Sensation and perception. So I gave you that overview. I have sensation and then the one for perception. And then there's a quick little reading in the back. Okay. No overall questions for you, sir? Alright, so what I did was I put a couple questions on the board, or I put a couple, I would say, questions that relate to the terms together. Alright, and then I have the word bank. If you look at like general terms, it's like a handwritten awesome copy of what I did. I have a word bank there that could match up with the question. So if you were to see, there's no spelling errors here. If you were to see this question, what allows you to read that question using expectations, experience, plus detecting the pieces of sensory information? So if you look at the word bank on the side, top down, bottom up, absolute difference, selective attention, simple messages, Weber's law, sensory adaptation, receptive transduction, sensation perception. You can take a minute or two to think about what you put for number one. Alright, second one, you're sitting at a table in a crowded cafeteria when a fight breaks out and you are so involved in your conversation you actually miss the fight. Alright, 3, the minimum amount of stimulus one needs to know there is sensory information present is called what? So the minimum amount of stimulus in order to know that there's a stimulus present. So like maybe a teaspoon of sugar in 2 gallons of water, the bee's wing. Okay, and then Brittany picks up a weight that is 10 pounds, then picks up a weight that is 11 pounds. The increase in 1 pound is enough for her to tell that there's a difference in the weight. This means the weight has hit its what? Alright, in order to feel an increase in the 100-pound weight, you need to increase the weight by 10%. The idea that the weight must increase by a percentage rather than a set number. What is this called? There's a grill on there. That grill has a name. I help you. Grill has a name. The company. What's the company?
I don't know. I mean, I know the answer.
Oh. Have you ever heard of a Weber grill? There you go. Alright, number 6. During a movie, okay, there are very brief pictures of popcorn and candy from concession stand. This message is happening just below the level of the absolute threshold. What kind of messages are these? Just below it. So your consciousness doesn't even detect it. It could be words that come across on a song on the radio. It doesn't just necessarily have to be pictures. Yeah. Subliminal messages. Okay? And we're going to go through these. I'm just kind of rolling through them right now. We're filling in the little questionnaire under general terms on the second page. We're just taking a guess. Susie walks in the room and smells delicious pies. After a few minutes, Susie no longer notices the smell. She used to the washroom. What? No. Just warming them up here. Sensation is the body's ability to detect a stimulus, and the brain interprets it. The brain interpreting it is known as what? Alright, so backing it up a little bit. What type of processing allows you to read this message? What do you guys got? Top down. What's top down processing?
Use your experience and stuff to actually like using your experts.
Okay, you use your experiences, you use prior knowledge to help you identify something. So the difference, you need to know the difference between top down and bottom up processing. Okay, remember top down. Okay, you start at the top of your head, you're using your prior experiences to help you identify something. Bottom up is you're using your senses to figure out that environment. Okay, so if the lights went off, okay, in this classroom, I'm not used to this classroom. So I would probably use bottom up processing to get myself through the class because I have no prior experiences. However, if it was my classroom and the lights went out, right, I might be able to use top down processing to walk my way through the classroom because I have prior experiences. I showed you guys a video of a guy that was talking about a restaurant he wanted to go to. Okay, and he was talking about that he had some information from other colleagues and information from other friends that they said the restaurant was really good. So he has prior knowledge going into this restaurant, so he has some top-down processing going into the restaurant. If you've never heard about the restaurant, you were in Spain, and you came across the restaurant on the street, okay, you'd be processing it all bottom up, using your senses to interpret that. Okay, confusing pair, but make sure you guys know the difference between those two. Alright, another one we looked at, you're sitting at a table in a crowd and all of a sudden there's a fight that breaks out, but you're so attentive to your conversation. What is that known as? Selective attention. Okay, we talked about this yesterday, people with training and heavy with selective attention. Alright, the minimum amount of a stimulus that needs to be present in order for you to detect it. You know which one is this?
This is the one that Marlene said I'm having trouble with these words. This is the absolute threshold. Okay, so I can send this PowerPoint out to you guys too if you want it to help you review. Okay, it's the minimum amount of stimulus that needs to be there for you to detect it. So, in our classroom right now, especially my classroom, 152F, okay, there's no bells. And you guys are all like jumping up and you're like, I don't hear it. Like, I'm like, all right, you guys can go. And you're like, what? I didn't hear the bell. So there's a minimum amount of stimulus there that I can still detect it in order for me to notice that there's some sort of change. Okay? I think that where the book says a teaspoon of water, okay, if you dropped one little drop of sugar into a gallon of water, you wouldn't be able to taste it. It has to hit that threshold. If I poured a whole teaspoon, still might not be able to taste it. But they say if you put 2 teaspoons in a gallon of water, you'll be able to taste it. Okay?
Versus the difference threshold, okay, this is that you're noticing that there's a substantial change in weight, okay, or there's a difference in the stimulus. So if I told you versus, you could probably tell my voice on the PowerPoint versus Ms. D's voice on the PowerPoint. You can tell that there's a difference in the stimulus. I can tell the difference between Pepsi and Coke. There's a difference in that stimulus. Okay. The person that experimented with this one is Weber, and that's why I had a picture of the Weber grill. Alright, he was the one that said there needs to be a significant amount of a difference in order for you to detect a change. Okay, so whether it's, if I had 10 quarters, let's say I had 100 quarters and 101 quarters, would you guys really be able to tell the difference? 100 quarters and then 101 quarters. 100 paper clips and 102 paper clips. No, there's not enough difference. So when he says it has to be about 10%, okay, times the amount that you're actually doing in order to identify a difference. Difference threshold. This is Weber's law. Okay, it's the law that associates with difference threshold. There needs to be a significant amount of change in order to detect it. Alright, the next one, during the movie, this is what Sweetie was walking into. Okay, that you notice something below the absolute threshold, those are subliminal messages. Okay. Susie walks into the room, she no longer smells the pie. What's that notice?
sensory adaptation. You guys walk into my classroom in the morning or in the afternoon, you're like, oh my god, it's so cold, and it's like 10 minutes of complaining, and then after a while, it's like you guys forget that it's cold. Your senses get used to it. The people who do like swimming long distances in like the Atlantic Ocean, I think that they have over time are able to adapt to those senses. Okay. And then obviously this one is what? Perception. Know the difference between sensation and perception. If you had to describe the difference between sensation and perception, how would you describe the difference? I had you guys write a list of words between sensation and perception. So write maybe 2 words that you could use to describe sensation and 2 words to describe perception. What's some terms that you could use to describe sensation? Detect. Another one. Pick up. Receive. Stimulus? Sure. What else could you use? What about these things? What are these things? Eyes, your nose, your tongue, your ears. What about for touch? Skin. Okay, so sensation is the ability to be able to detect it. Okay, then how would we describe perception?
Smell.
Interpret. Analyze. Oh no, interpret. Too early for me. Analyze. Transduction, yeah. What's transduction, sweetie?
When you get the sensory chemical or waves from your receptor and then you change it into your
Yeah, and you change it into a little neurotransmitter. Okay, if you guys remember what a little neuron looks like. Okay, so transduction is the process of where you change the light wave, the sound wave, okay, the chemical into a neural stimulus. Okay, what if somebody has problems with being able to detect sound waves? Okay, their sensation might be damaged, which then is not, they're not going to be able to perceive it very well. Okay, what if somebody's ears work really well, but something malfunctions when it gets to the brain? That's going to mean that they're not able to perceive it very well, perception. So making sure you know the difference between those two. Okay, hence then we started going through all the different senses. So sight, sound, you should be able to know taste, what else? Smell, and touch. Alright, so right on below it, alright, it says sight. Okay, describe the mnemonic device first for how light enters the eye. Can you remember that mnemonic device? Or, for the sense of sight, what's the receptor, what's the stimulus, and where does transduction take place? You guys can remember sight. Let me see if you remember that mnemonic device. Mark, open it up. There you go. Sight. Yeah. Jim?
Okay, so for all of them, you should be able to detect on there, like it said, the receptor. You should be able to know the stimulus. Okay, and then you should know where transduction takes place, at least for sight and for hearing.
Steve needs to be marker. Perfect. All right, Sam, what's the receptor?
Your, eye.
Good. What's the stimulus?
Light.
Yeah, light waves. Where does transduction take place? Yeah, in the retina. Good. All right, and then what about that mnemonic device, how it enters the eye? Chubby Irish people like rolls. Okay, so when light enters through, it enters through what's C? Cornea. Iris. Pupil. Lens. Retina. The retina has 2 photoreceptors in it. Cones and rods. Which ones allow you to see color? Cone, C, color. And rods allow you to see black and white. Where does transduction take place? The retina. Okay? That help a little bit, warm you up? And so let's look at the first one. Same thing, there's a word bank on the side. We'll take a look at question number 9. We'll go through the questions real quick and then I'll come back with the answers. Alright, so it gives you a minute to think about it. Alright, so the covering of the eye that protects it. Just jot down number 9, you think it is. Pictures may help to process that. Alright, number 10. Part of your eye that holds color, your genetic information, okay, and contracts and expands to incoming light. It's not pupil. Okay. The hole in the middle of the eye that lets light in. Again, I can send you this PowerPoint if it's helping you. And the next one, the part of your eye that changes shape or shows a combination to incoming light. Combination, what's a combination? Think about accommodations when I'm giving a special education test. They don't take the same test that you guys take. Okay? They may take a simpler version. So I have to use accommodations. So it's what? Basic changes. Okay? So the part of your eye that changes the shape and allows for changes or processing to take place. Where if I were to all of a sudden move closer to Sweetie, I was going to get a lot bigger. Your eye is processing those changes. I'm not like the little small person that I'm all the way back here. Okay? You look about this big to me. Right? But when I get closer, you look a little bit bigger. Alright? So what part of the eye helps with that? Okay. And then the back of your eye that contains all the colors and black and white receptors is called what? So that might help from before. Back of your eye, transduction takes place here. Alright, and then an animal who is nocturnal is typically awake at night. Nocturnal. Okay. Can see better at night than other animals. This means the animal probably has more of these, or receptors that help them see black and white. Bats may have more of these. 15, the color receptors are called blank and are mostly found in your what? This is an F. Look at your word bank here, that might help you. 16, process where stimuli is changed to an impulse. Okay, specialized nerve cells in your brain that help you see features of objects. So these are those things that help you understand movement, size, shape. They're located in the occipital lobe. Begins with an S. Begins with an F. Baby? Only got one other F word left. Okay. This theory of color says that we have three main color cones, red, green, and blue. Yes, it's called the trichromatic theory, but there's another name. Yep. The person that came up with it. Yes, sorry, two people. Young and someone else. And then the theory of color that says that we have opposing nerve cells in our occipital lobe. It's often known as creating after images. This is known as what? How'd you do? Beautiful? All right, let's back it up real quick. All right, so the covering of the eye protects it. Everybody? Why is it corn? Corny? Helping you. Okay. All right, the part of the eye that has color in it and contracts and expands, it has your genetic information. It's the iris. Okay. Next one, part of the eye that lets light in, your pupil. Okay. Part of your eye that changes shape and shows a combination. Lens. Helps focus the light. Helps focus the image. Lens. Okay, that's what your lens does. All right, back of your eye has color, light receptors, retina, and then obviously the one that helps animals see in the dark is going to be what? Rods. Where are rods located? In your peripheral. Okay, remember when we did the exercise, you were only able to see black and white in your peripheral. Where are the cones located? In the center of the retina. Okay, which just helps us process color. All right, the color receptors are called
cones, right, and they're mostly located in the what? Fovea, which is a part of the retina. Okay, after it goes to the fovea, where does it go? Optic nerve. Okay, so after it goes to, I think we got the retina over here. Okay, and there's a part of the retina. This D really needs new markers here. It's the fovea. Okay, now it's a little chemical impulse. Right, it's going to go to the optic nerve. To everywhere but smell. Thalamus. And then where's it going? Occipital lobe. We did lots of exercises in class that looked at that. So go back and look at some of your I know worksheets. Right, but it goes to the optic nerve. The nerve then takes it to the thalamus. And then the thalamus takes it to the occipital lobe. Okay. 16 here. Process where stimuli changes to an impulse. Transduction. Okay. Specialized nerve cells in your brain that help you see the main features. Feature detection. Alright. Which theory was this? The Young-Helmholtz? Trichromatic. Alright, and then optic nerve. No, component processing. Okay? Alright, let's take a look at hearing. Okay, on the next slide. So we're on through here. Alright, so what's the mnemonic device? I know some of your classes made up a mnemonic device, and for the life of me, I cannot remember it. Okay, so don't say it right now. Right, and then receptor for hearing, the stimuli for hearing, and where does transduction take place? Maybe take a minute and look at that. All right, Mira, let's just go through, what is the stimulus? Sound waves. Is the stimulus. So like the other one, like sight, you have to know the stimulus. What's the receptor? Ears. Okay. Receptor, obviously it's the ears. So you need to know the parts of the ears. And then where does transduction take place? Cochlea. All right, Alexis, what is it? P? All right, so help me out here. Hammer, anvil, stirrup, cochlea. I know that's what you guys call it. Yeah. Coachella, I get it. Auditory nerve, and then thalamus. And then after the thalamus, where does it go? Temporal. Okay, so it goes pinna, which is your outer ear, which is in a funnel shape to help funnel in the sound. Okay, and then you have your ear canal, okay, which is the part between the outer ear and the inner ear. Right, and then you have the eardrum, which is sometimes known as the tympanic membrane. Okay, and then you have the three little bones. Remember, these help create vibrations on your cochlea. Okay, the way I remember it is has. So if it asks the order, we have the three little bones, at least maybe you'll remember that. Right, then you have the cochlea that looks like a snail. That's where transduction takes place. Then you have the auditory nerve, the thalamus, and then the temporal lobe. Okay, again, where does transduction take place? We heard from Mirna. Okay, it takes place in the cochlea. I think it was Mirna, right? Somewhere. All right. Okay, so let's take a look at these questions real quick. All right, 20. This should help you then. Okay, the outer ear collects the sound waves from around you. This area is known as what? There's a pin on there. All right. 21. The sound travels through your ear canal and hits the blank, which creates the incoming sound and protects the middle ear from your inner ear. Again, I put a word bank for you there. Visuals help you with memory. iconic, keep going. Alright. In the middle ear, the sound is amplified by 3 little bones which vibrate to the sound waves. These little bones are called what? As we just went over it. The message travels to the snail-shaped coil in the inner ear to transduce the message to the brain. The snail-shaped coil filled with fluid and hair to react to the sound is called the what? Sorry. Alright, next one, now you got 2 theories. Okay, this theory, okay, the person who came up with the first vision theory also came up with one for hearing. Okay, he also had a theory about the sound perception. This theory says that the location the sound wave hits determines the sound we hear. So the place it, the position that it hits, okay, on the cochlea, it's going to determine the sound. Right, so if you had your little cochlea here, okay, and remember we talked a lot about this, there's little hairs on here. Over time, remember these little hairs start, if you're listening to loud music or old age, these hairs start to go away. And these hairs help you identify high pitch. Hence why Miss Gavin can identify maybe high pitch and you guys can't. Okay, so this is the place theory. Okay, if you guys remember this, the place that it hits on the cochlea is going to determine the pitch. All right, and then we got 25. All right, this is another theory. The other theory of pitch perception says that the pitch we hear is based on the speed, how often they come in. Okay, if they're really fast, it's going to be a what pitch? If they're really slow, they're going to be a what pitch? I'm so glad I'm recording this. You're going to hear my wonderful voice. You can hear it over and over again. All right, this theory helps explain why we can't hear supposedly some pitches. All right, and then the 2 different types of deafness. The 2 different types of deafness, and maybe take a minute and see if you can tell the difference between the 2 different types. One you're born with, one happens over time. You got it? Alright, so 20, everybody. The outer ear. Pinna, right? Alright, 21. The sound travels through your ear canal and hits a certain area. Tympanic membrane. Alright? 22. The middle ear has what? Where are the 3 little bones? Hammer, anvil, stirrup. Those are the 3 little bones. Remember, we did the little dance when you guys were going through the ear. Okay? The message travels to the what? The snail-shaped area, cochlea, that helps transduce. The person who came up with the first theory, this is known as the place theory. I went over it with you. All right, and then this is the what? Frequency theory. Okay, and then the last one is conductive hearing loss and sensory neural. What's the difference between the 2? Sandy, you know? Yeah, so sensory neural. Something happens when you're trying to send the message from the cochlea, that little neuron, to your brain. Something's wrong with that auditory nerve. The message isn't getting there. Sensory neural. Can't really fix. It's neurological. You're born with it. Okay? If you look at conductive, conductive is looking at the damage of the hammer, anvil, stirrup. Over time, this could happen. So if you guys remember Tyler, okay, he is in your class. He was the one that presented on he had conductive hearing loss. Right, so something was happening where his little, the vibrations weren't being made on the membrane, so he wasn't able to hear. And hence why he has a hearing aid to help amplify the sound. Okay? Questions on this? Alright, so questions overall, if you guys take a look at the front side of the sheet, maybe take a break for a minute. Alright, we went over the sensation, the basic terms there.
Okay? You gotta know we started with, I think, the first 8 questions was just looking at the basic terms. We just went over it. One term on there that you might not know that we didn't go over is psychophysicist.
Yeah.
What is that? Somebody who studies what? Psychology, yeah. But what specifically? Okay. What unit are we in? So somebody that studies sensation and perception. Okay. Somebody who looks at studies with sensory adaptation. Somebody who looks at studies with selective attention. Right. We talked a lot about vision. Okay. As you're going through the list there, maybe you don't remember light waves. Oh dear gosh, this is taking me back to physics. I can draw a wave here. Okay. What is helping you identify color? You got 5 minutes. But what is helping you identify color? From peak to peak. Right? And what's identifying how bright that color is? Okay, the height of the wave. Right? And if this is something that you want to go over at another review session, like, oh, I can't hit every single topic, that might be something that you want to look at. Okay, we did a pretty good job understanding vision. And the last thing we did a pretty good job at was hearing. Okay, I will finish the rest of the senses on Thursday morning. Okay, so if you want the rest of the senses, touch, taste, smell, I'll give them and go. Yeah. Okay, does that help? Yeah, there's right back on the table. That's all I have left for this right now. We have to wait for anyone. One more. Does that help you? You're all good? Okay. Cool.
16.
What?
16? 16 kids.
Yeah. That's good. Hold on, let me stop this. Like recording.